All right, hey guys, so I wanted to go over the second set of homework that we're doing to get ready for our first interim test, and I wanted to show you where I'm putting this in Schoology. So if you log on to Schoology and you come here, or if you just click on materials, you'll end up at this page, and you click on the interim folder and homework. I created a page in here, and if you open that, you will see here was our first day's homework, right? And we had all of this. And then right below that, I put a link to the video where I had the answer. And then today's homework questions are right below this, day 2. And when I'm done with this video, I'll put a link under here with those answers. I'm also sending this video out on Remind so that you guys can get those right away. But let's go ahead and get started. So we're talking about working with systems of equations. And our first question was, the school that Stefan goes to is selling tickets for choral performance. On the first day of ticket sales, the school sold 3 senior citizen tickets and 1 child ticket for a total of $38. You guys, is this the second question? Did I do the second question first? Let's see. Yeah, here's the original one. Sorry, guys. The admissions fee at a small fair is $1.50 for children and $4 for adults. On a certain day, 2,200 people enter the fair, and $5,050 is collected. How many children and how many adults attended? So I'm going to look at that where the question mark is, right? And I'm going to use that question mark in order to define my variables. Remember, defining your variables is super important when you're solving a systems of equations. And I'm going to use C for children and A for adults, and we're trying to figure out how many people attended, right? So we're going to go ahead and say C is equal to the number of children who attended the fair, and you guys are probably ahead of me. A is equal to the number of adults who attended the fair, right? That's attended. If you're just watching this and not listening to it, you should be listening. You get a lot more out of it. Okay, so what do we know? We know that one day, 2,200 people entered the fair. So this is where these things start to get tricky, because how do we turn that sentence into an equation? Well, on a certain day, the number of children and, right, the number of adults who came to the fair was equal to 2,200, right? You don't need that comma because we're going to be solving this, 2200. And then we know that all of the tickets sold made $5,050. So if it was $1.50 per, so we'll do times each children's ticket, and it was $4 for each adult ticket. So I'm going to multiply the amount of money times how many tickets were sold. Then we made, so if we add all of that money together, we made $5,050. Okay, so there's my 2 equations and 2 unknowns. This is set up in standard form. So I'm going to go ahead and I put a times there. You don't really need that. You could do 1.5c there if you're following my cursor. I'm going to do elimination because they're in standard form. So I need to have 2 numbers that are opposites. So I'm going to work with the A's. I'm going to work with the adult tickets because we have a whole number and sometimes that's easier. And what I'm going to do is, in order to cancel them out, I need to make this top one, I need to make this top A -4. Right now it's +1. I need to make it -4. So I'm going to multiply the entire equation. I'm going to multiply this entire equation because you can't just do this to one term in your equation by -4 to make that A -4. So if I multiply the entire equation by -4, what that looks like, I'll just put parentheses around the whole thing. Okay, and I'm going to distribute that -4 to every single number. Now, where I see a ton of mistakes is that they always forget to distribute it to the other side of the equal sign. Don't make that mistake. Let's change pen and numbers to do this. Okay, I'll make it blue. So -4 times C gives me -4C. -4 times positive A gives me -4A. Equals, do not forget the other side, -4 times 2,200 gives me -4 times 2 is 8. 4 times 2 is 8. And then 0, 0, -8,800. Okay. Now we are going to combine those. We're going to add these two equations together. Okay. And I'll change colors again. So these two are eliminated. So that's why we're going to be solving for C. So if I combine positive 1.5 minus 4, and you guys feel free to use a calculator. I'll open the calculator. So that would be 1.5 minus 4. Okay, you get -2.5C. So it's going to be -2.5C equals, and then on this side, so that was this part right here. On this side of the equation, I have 5,050 minus 8,800. So what that looks like on the calculator is 50, 50. And I know it's going to be a negative number because 8,800 is bigger. 8800. -3750. So, and that's cool because now I'm going to divide both sides by -2.5, right? So how about orange? I'm going to divide both sides by -2.5, -2.5. When I'm dividing a negative by a negative, I'm going to get a positive answer, which is good because we don't want negative people coming to the fair. So this cancels here. So I have the number of children, C, is equal to, and then I'm -3750 divided by -2.5 is 1,500. So we had 1,500 children come to the fair. But we are not done. We still need to go back and figure out, we need to use substitution, go back and figure out if 1,500 children attended the fair, then how many adults did. So I'm going to rewrite the easiest equation, which was one of our original equations, which was all of the children plus all of the adults was 2,200. Well, but I'm going to substitute in for C the fact that I know that it was 1,500 children plus some number of adults equals 2,200. So you could either figure that out in your head, or you could solve equations by subtracting 1,500 from each side, and it cancels out on this side, and then you get A is equal to, or the number of adults is equal to, use our calculator to make sure, oops, that's the wrong calculator. Make sure I don't make a mistake here. So we have 2,200 minus 1,500 is 700. So the number of adults that attended was 700. So each adult approximately had one child, right? It was a little bit more than double. So as always, please give your answers in complete sentences. So we can just quickly say 700 adults and 1,500 children attended the fair one day. Okay. All right, now let's do that second one here. Maybe I can fit it all in one, or actually, I'm going to pause, set it. No, let's just do this. Let's see if we can get it done. Okay, here we have senior citizen tickets and child tickets. So let's just do C is equal to adult, the number of adults. And we'll do, oh, why did I say that? Let's do C is equal to the number of children. And instead of senior citizens, let's just make them adults too. Or you could do S. We could do S. S is the number of senior citizens. Okay. And here it says the school is selling tickets for choral performance. On the first day of ticket sales, the school sold 3 senior citizen tickets and 1 child ticket for a total of $38. The school took in $52. The second child by selling 3 senior citizen tickets and 2 child tickets. So here it wants to know the price of each ticket. Oh, so let's change this. We don't want this to be the number of children. We want it to be the price. The price. That's what it's asking for, the price. And here, the price of the ticket, because that's what the question is asking for. So we know if we sold 3, and let me highlight this for you. This is the part I'm going to do. If we sold 3 senior citizens and 1 child's ticket for a total of $38, that means 3 children plus 1, 3 senior citizen ticket, so 3 S's plus 1 child was $38. And then the other one was 3 senior citizens tickets and 2 children's tickets. They get $52. So 3S again, but this time we have 2 C's, and that is equal to, what was it? 52. Okay, so the first thing I'm going to do to get an opposite, oh, look, we both have 3 senior citizen tickets, so all I have to do is make this one, the top one, negative. So I'm going to just multiply each term on the inside of that first one by -1. That's just going to change the sign of each of those. So -1 times 3S is -3S. -1 times +1C means -1C is equal to -1 times 38 is -38. I'm going to pause this and do the math so we don't run out of time on this video. Why don't you try to do the math and you also pause. All right, so hopefully after you combined that, you saw that C was equal to 14. So a child's ticket was $14. So what I'm doing is I'm substituting that back into the original equation, which was 3S plus 1C, but I know 1 child's ticket was $14, was equal to 38. And we're going to solve for the senior citizen's ticket, so we're going to subtract 14 from both sides first. So 3 senior citizens tickets should cost 8 minus 4 is 4, $24. So you can divide both sides by 3, or in your head you could say 3 times what number is 24, and that is 8. So senior citizens tickets are $8 and children's tickets are $14. So in this case, children's tickets are much more. Please a complete sentence answer. But you can make it quick. Each children's ticket is $14 and each senior citizen's ticket is $8. All right, you guys, I will see you next class.